Welcome back to MonsterTamer, our 2D Pokemon-like RPG created with Phaser 3. In our last video, we reviewed the new dynamic camera feature that we're going to be implementing. If you haven't seen the previous episode, you can find a link in the description. As always, you can grab the project source code up to this point, along with the completed code for this video, from the links in the description. I'll also include any assets you'll need to follow along, so let's get started. To start building our new feature, let's jump over to Tiled, and we'll want to open up our main area level. First, we'll want to make a new object layer. For our object layer, we're going to call this Camera Bounds. Let's move that up with our other object layers. Now for our Camera Bounds layer, we need to define basic rectangle shapes that we can use in our Phaser code to bind our camera to those dimensions. So as an example for our starting area, we'll want to create a rectangle shape that matches this part of our image that's visible. In our Phaser code, when we load in this object layer, we're going to use this rectangle shape, our dimensions, so our x and y value, as well as our width and height, to define the bounds for our camera. And that will give us the result of only this part of our image will be visible to our player. So now to create our new camera bounds objects, on our camera bounds layer, let's use our encounter tile. We'll do insert tile. Let's add in our tile in our bottom left hand corner. And now we need to define our width and height we want this rectangle to take up. So for our width, let's do 1536. And so now that's going to have our rectangle take up our current visible area. And now we'll want to do our height. And for this, we want to do 3584. So for these dimensions, we're just taking the number of tiles we want to be defined in the zone, and we're multiplying it by 64. And so now we have our first zone in our game where we're going to bind our camera to. Now we need to do the same thing for our town area. And now for our second town, we'll want to define a rectangle that takes up our full width, so we lock our camera to that bounds, but we'll want this to be much smaller than our first rectangle here. So to create that rectangle, let's do our camera bounds layer, we'll do insert tile. Let's add in our tile down here. So now for our width, let's do 2560. And now for our height, let's do 1280. Now we just need to create our camera bounds for our forest area up here. So now for our bounds, we'll want this to partially overlap with our existing rectangle, so we'll choose this tile here. For our width, we'll do 1536. For our height, we'll do 896. Finally, for each of our camera bounds objects, we'll want to give each one a unique identifier. So for this, we'll create a custom class that we can assign to each of these objects. So let's go up to View, we'll go into our Custom Types editor. Let's add a new class. We're going to call this Camera Bounds. So in our class, we'll add in one member. For our type, we'll do an integer, and we'll just call this ID. We'll have a default value of 0. So now for each of our objects, we'll want to select that class. We'll do an ID of 1, ID of 2, then we'll do an ID of 3. Finally, we need to do the same thing in our forest level. So let's copy the name of our object layer. Let's jump over to our forest level. Let's add in our new object layer. We'll update our name. Let's choose our encounter tile. We'll place it in our bottom left-hand corner. And now for our width, we'll do 1280. Now for our height, we'll do 768. And let's go ahead and save. Now that we've added our new object layers, we just need to export out our files as JSON. Let's do File. We'll do Export As. We'll do our forest_1 JSON. Now for our main level, we'll do File, Export As. We'll do main_1 JSON. Now we just need to import our new JSON files into our Phaser code. So we'll want to make sure we place our JSON files under our assets and our data folder. And so we'll want to replace our forest_1 and our main_1 JSON files. Now that we've imported our JSON files, we need to update our world scene to parse our new tile object layer. So in our world scene, let's add a new property to keep track of all our camera regions. So at the top of our file, we'll add a new private property. We'll call this camera regions. And now for this property, this is going to be an array of objects. For our objects, let's define that property in our type definition file. So I'm going to add a new section. I'm just going to call this camera region. I'm going to grab one of our other object definitions. We'll paste that here. Now for our type definition, I'm going to call this camera region. And on this object, we'll have 5 properties and they'll all be numbers. Our first property will be the ID of our region. Let's copy this, paste it. Then we'll have our X position, we'll have our Y position, and then we'll have our width and height of that region. Now that we have our new type definition, we'll jump back to our world scene. Let's add in our type to our camera regions. So for our type, this will be our new camera region. We want this to be an array of those objects. Next, we'll come down to our init method and we'll initialize our value. So we'll do this, our camera regions, and we'll set equal to an empty array. So now down in our create method, this is where we'll populate our array. Let's come down to our create method and we'll go to where we update our camera. So after we have our camera start following our player, we'll update our camera bounds. So now to get our camera bound objects, we need to take our map from tiled and look for our object layer that's called camera bounds. Once we have that object layer, we'll need to grab all of our objects and then use that to create our camera bounds objects that we just defined. So now to add in this logic, instead of adding it to our world scene, since it's getting quite large, we're going to start moving some of our logic for tiled to a new file. So under our source folder, under utils, let's make a new file. We're going to call this tiled utils.js. So now inside here, this is where we'll add in our functions for getting that object layer. So first we'll do export function. For our function name, we're going to call this create camera regions. For this function, we'll need one argument. This will be our tiled map. So for our map, this is going to be our phaser, our tile maps, and then our tile map. And then from our function, we're going to return our camera region array. So now in our function, we'll need to create that array. So let's do const, we'll do our camera regions. We're going to set it equal to an empty array, and let's just return that empty array. So now in our function, we're going to need to take our tile map. We'll want to look up our object layer for our camera bounds, and then return all of the objects that are on that layer. For that, we'll make a new utility function. We're going to do function. We're going to call this get objects from layer. For this function, we'll need two arguments. First will be our tile map, and then we'll need our layer name that we want to grab the objects for. So now to get those objects, we'll do const layer. We'll do equal to our tile map, and when I do get object layer, now we need to pass in our layer name. Now we'll add in a safeguard. If our layer doesn't exist on our map, then we'll return an empty array. If our layer does exist, then we want to return that layer and our objects. So now back down in our function, we can do const. We're going to do our objects will be equal to, we'll get our objects from our layer. We'll pass in our map. Now for our layer name, we're going to do camera bounds. So instead of hard coding our string value like this, we're going to create an object that keeps track of all these values. To create that object, we're going to create a new utility file like what we do with our asset keys. So we go under source, our assets, let's make a new file. We're going to call this tiledkeys.js. Now we'll want to export out our object. So we're going to do export const. We're going to do object layer names. We're going to set it equal to our object.freeze. And now for our object, we're going to have one property. We're going to call it camera bounds. And now we'll set it equal to our camera bounds layer name. So by placing all of our layer names inside this object here, this will allow us to modify all of this code in one location. And for the time being, we'll only add in our camera bounds object layer, and we'll come back and update this later. So now if we come back to our tiled utils, we'll get rid of our hard-coded string. Now I'll reference that layer. So now that we have our tiled objects, we can iterate through our array and create our camera bounds objects. So let's take our objects array, we'll use map, and then for each of our objects, we just want to return a brand new object. And on our object, we'll need our ID property, our X, so we can grab this from our object. We'll do our Y, we'll grab that from our object. Then we do our width and height. So we'll do our object.width, and then our height will be our object.height. So now for our Y value, we'll want to make sure we subtract the height of our object. The reason for this is our object's in tiled. Our Y coordinate is going to be at the bottom of the object we created. Finally, for our object, we just need to update our ID. So we're going to do our object, we want to do our properties, and now we want to do find. So now we'll have our property, and we want to find where our property name is going to be equal to our ID. And once we find that property, we want to return that value. So now if we want to test our code, let's jump over to our world scene, and let's update our property. So we'll have our camera regions, we're set it equal to, we're going to do tiled utils, and now we want to call our new function. So we'll do create camera regions. And now we want to pass in our map. So let's do console log, and we'll do this, our camera regions. And now we just need to update our imports. So let's copy this. We'll come to the top of our file. let's do import star as tiled utils from under utils, and now we want our tiled utils. All right, so we save. Oh, we have an issue. We'll come back to our tiled utils. We need to fix our import. So this will be our tiled keys.js. So now if we go ahead and start our world scene, we should see our new console log statement with our 3 camera bounds objects. Now that we validate our logic's working, we're going to make a small change to our logic in our tiled utils file. So when we create our camera regions object, we need to have our ID property, since that's how we keep track of each of our unique regions. When we get our objects from tiled, our X, Y, width, and height will be populated, but our ID, this was a custom property that we added. So when we process our objects here, we want to make sure each of those objects already has the properties that we're expecting. So to do that, we'll make a new utility function, and we'll do function, and then we're going to call this getObjectsFromLayer with ID property. So now in this function, we'll pass in our map, we'll pass in our layer name. So first, let's get our objects from our layer. So we'll call our other function, we'll pass in our map, our layer name. Now for these objects, we'll want to filter our array. So we'll do objects, we'll do filter. Now for each of our objects, we'll want to return objects that have our ID property. So we're going to do return, we'll do our object, our properties array, and on that array, we'll use the sum method. And now for our property, we just want to return if our property name is equal to our ID. And then from here, we'll return our filtered array. So now down here in our other function, we can update our logic. So instead of doing getObjectsFromLayer, we're going to do getObjectsFromLayer with ID property. I'm just going to update our variable name. We'll do filtered objects. So now if we save, go into our world scene, we should still see our console log with our 3 objects. And so by doing this, we're just adding an additional safeguard to make sure we have our ID property on our objects. Now that we have our camera region objects, we can use those along with our player's position to update our camera bounds. To do this, we'll need to take our player's coordinate position, so our X and Y value, and then compare it to our camera region's X and Y value and our width and height. If our player falls within inside that rectangle, we'll know we're in that camera region. And so for our check, we'll want to make sure we return every single region that our player is currently inside, so we can update our camera bounds accordingly. To add this logic, we're going to create a utility file for our camera. So under our source, under utils, let's do camera utils.js. We'll do export function. We're going to call this update main camera bounds. So now in our function, first we'll need our phaser scene, and then we'll need our game object so we can grab our X and Y values. And so in our case, this will be our player, and then finally, we'll need our camera regions. So now in our function, we'll need to take our game object's position, and then find all of our camera regions that game object is currently inside. For that, we'll make a new function. We're going to call this getCameraRegions for game object. Now in this function, we'll have 2 arguments. First will be our game object, and then we'll have our camera regions. So now in this function, we just want to return an array of our camera regions that our game object overlaps with. So we're going to do return, we'll do our camera regions, we'll use our filter method. And now for each of our region objects, we'll want to return where our game object, our X value is greater than or equal to our region, our X value, and our game object, our X value is less than or equal to our region's X value plus our width on our region. And now we'll do the same thing for our Y values. So I'm going to copy these 2 lines of code. So we'll just do and. So now I want our game object's Y value when it's greater than or equal to our Y, where our Y value is less than or equal to our region's Y plus our height. So now down our function, we'll do const, we'll do filtered regions, will be equal to our get camera regions for game object. So we'll pass in our game object and then our camera regions. Let's do a console log and we'll test our logic. Let's jump over to our preload scene. We'll switch from our title scene to our world scene. And now we just need to update our world scene to call our new function. So I'm going to come to the top of our file. I'm going to copy our import statement. We'll paste it. Let's do our camera utils. We'll remove our console log for our camera regions. Now we'll do our camera utils. We'll call update main camera bounds. We'll pass in our phaser scene. we're going to pass in our player and then our sprite game object. Then we're going to pass in our camera regions. So now if we save, once our game refreshes, down on our console, we should now see our array, and it should only have one object since our players are currently only overlapping with one region. Finally, back in our camera utils, we can now update our camera bounds on our main camera based on our filtered regions. So first we'll add in a safeguard, so we'll do if our filter regions, if our length is equal to 0, then we'll just return early. If we have more than one object, for the time being, we're just going to grab the first object and use that to set our bounds. So we'll do const region will be equal to our filtered regions, and we'll grab our first element. And now we can update the bounds on our main camera and our scene. So we'll do our scene, our cameras manager, we'll do our main camera. Now we want to call set bounds. And so we'll do our region, we want to do our X value, we'll do our Y value. Now we'll do our width, and now we want to do our height. So now if we save, as soon as our game refreshes, we'll see our view is now updated, and we no longer see that black rectangle around the edge of our screen. So with the logic we've added so far, this is going to work for once our phaser scene first starts, but once our player goes to move into a new region, we'll need to update our logic to reset our camera bounds. To see an example of this, let's jump over to our world scene. First, I'm going to disable our wild encounters, so now if we have our player move, let's head up to our second town. And so once we get near our second town, I'm going to go ahead and save. So now if we head up, we'll see our camera still bounded to our first region. And so to fix this issue, we'll want to update our camera bounds after our player moves. So let's copy our line of code where we update our camera bounds. Now let's go to our handle player movement update method. So after we update our player's position, let's update our camera bounds. So we'll paste in the same line of code. Alright, so now if we save, once our game refreshes, if we have our player approach our second town, we'll see our camera's not updating, but once we leave that region, our player is now in our next region and our camera is now updated accordingly. So now if we do the same thing and head up to our forest, we'll see our bounds is locked to our second region. Once we leave, our camera jumps and updates, and now it's in our third region. So now that we have our core logic in place, we just need to address the issue when our player is in multiple regions, since right now we're just grabbing that first region from our array. Alright, that's going to wrap up this episode of MonsterTamer. In our next video, we'll continue working on our camera bounds logic and we'll address our issue with multiple regions. You can find the complete source code for this video in the description below, along with the links to the full series if you need to catch up. If you enjoyed this episode, give it a thumbs up. It really helps others find the series. And if you've been enjoying the phaser tutorials and want to support the channel, I've set up a Ko-fi page. Even a one-time coffee helps me keep making more content like this, and the link's down in the description. Don't forget to subscribe and hit the bell so you'll know as soon as the next episode is out. Thanks so much for watching, and I'll see you in the next one.